So let's get into the feature of the day, starting with flexible return and event delivery, Fred. So Fred is now enabled by default. Now, what is Fred? Why do we care? What the fuck does it do? Well, when we're talking about Fred and events, we're talking about event meaning interrupts, exception, and syscalls. So why are we talking about all of that? Why do we need to change that? Well, my wording is way too complicated here, but I'm waking up, okay? Let me just read it. Why are we talking about this now? So, with Linux 7.1, Fred is now enabled by default for compatible CPUs. For now, this means only Intel Panther Lake, but we will soon see Intel Diamond Rapids and even AMD Zen 6. Because, yes, Fred, which initially was an Intel exclusive, will be brought to AMD. We can thank the x86 ecosystem advisory group for that, which contains Linus, by the way. Now, what's the goal of Fred? So Fred seeks to fix the issue with the current way of handling interrupt, exception, and syscalls. And syscalls, because on x86, they are broken. So let's just go through some example of that. We have the fact that there's no facilitation of the kernel mode and user mode handling, so the ring handling. There's the loss of register values that are not manually saved by the kernel, so that's kind of bad, and also the limited information on the source of an interrupt. Now, how on before understanding no before getting into Fred, we must understand on understand. I hate that I have this in my field of view. Okay. Before getting in Fred, we must understand how the previous system works. And that's the interrupt descriptor table. That's how we write it, right? The IDT. Since the very start of x86, back when we were talking about 16-bit CPUs, contains the that's redundant. So an array of pointer that contains that's is used to determine the address of the address of the handler for a specific interrupt. Some are hardware enforced and others are software and others can be changed by the software. And at that point, we should probably show the whole table. Let me just go to my bookmark and Or not. Cool. That's what I want to show. All right. Um, whenever an interrupt is declared, executed, is executed. Whenever an interrupt is executed, the CPU will get the address of the handler from the IDT, which should which will nah. Let's go step by step. Okay. Let's go step by step into what happens when an interrupt is executed. AI come to the rescue to make my life easier. Okay. One. Once an interrupt is declared, is executed, the CPU will push some information onto the stack. Now keep in Now, quick remind, quick reminder that stack is the number one way for the CPU to keep information, to keep data. So when we say push onto the stack, so pushing into the stack adds data to memory while popping out of the stack removes from memory. Once an interrupt is executed, the CPU will push some information onto the stack. Now, quick reminder, the stack is the number one way for the CPU to keep data, so pushing onto the stack adds data to memory, while popping out of the stack removes from memory. Here is the information that is pushed onto the stack. One SS. Okay, one, the stack segment register, two, the stack pointer register. What the fuck are R flags? R flags register. What is the R flag? R flag register. No, not flag register, R flag. I guess we're not going to talk about it. The R flag register. CS. The code segment register. Why am I getting spammed? I don't consent. Ooh. It's important. I do consent then. Whoop whoop. Making money. Okay. Instruction pointer. So the REP. And the error code. Not always there. Depends on the interrupts slash exception. This structure is called the iret frame because it is used by iret by the iret instruction to return from the interrupt. Now the core issue here is that there is no brain. I need to start drinking my coffee. Now the core issue here is that there is no no information on the that's a bad way to say it. Po, 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 po. The kernel would then need to manually save all the registers it fears losing while processing the error. This would be done in software, so very slow. Could also need to confirm that um no, that part is okay. Now if let's take the example of a syscall. Syscalls would work in a similar way, but they are, but they don't have the advantage of the CPU constructing the IRET frame. Alright, this means that that this means the kernel had to okay, brain, focus. This means the kernel had to save not only the registers that it fears losing, but also the IRET frame in software. This is this is very slow, but was the only way to keep compatibility. Keep in mind the same idea. Same idea exists since x86 conceptions. Now, Now, what about Fred? Fred fixes this by doing a couple of things. One, one, Fred will change. No, Fred works by changing the behavior of the behavior of the CPU. How do we write behavior? Okay, behavior of the CPU when it comes to events. Syscalls now have will create the new will create the new Fred frame onto the stack. Okay, syscalls will now create a new Fred frame into the stack. Interrupts and exceptions. I never know how to write exceptions. Exceptions. I think that's one of those words that is written different if you're in the UK or in the US, right? Interrupts and exceptions will leave more information within the new Fred frame. The CPU will recognize shit. The CPU now has specific instructions that are kernel mode / user mode dependent. This leaves less work for the software. Okay, let's just reread some of this. Let's go step by step into what happens when an interrupt is executed. Once an interrupt is executed, the CPU will push some of the information onto the stack. We'll push some information onto the stack. Now, a quick reminder, the stack is the number one way for the CPU to keep data. So pushing into the stack adds data into memory, while popping out of the stack removes from memory. Here's the information that is being pushed onto the stack. So we have the stack segment register, which is, fuck. Maybe I need to describe. Is it even used? Stack segment. Whoops. Should look on while I'm streaming. In AI, no, IA 32E does the register do anything? I guess that's an AI question that I'm asking. Okay, in Intel camera segmentation, therefore still enforces security. Okay. The null selector are allowed. Um, before going forward, need to understand that under a 64-bit machine running 64-bit software, a lot of the registers being saved are useless. For example, the only use of the SS register is to prevent the CPU from running is to prevent the CPU from running a user space stack with a uh, user mode stack with kernel mode. For example, the only use of the SS register and vice versa, right? That's what we just fucking read. The CPU. Maybe I don't need to go further than that. This structure is called the IRET frame because it uses the IRET instruction. Before going forward, you need to understand that under a 64-bit machine running 64-bit software, a lot of the registers being saved are useless. For example, the only use of the SS register is to prevent the CPU from running a user mode stack with kernel mode. It would be reverse, right? Kernel mode stack with user mode. This leaves most of the bits being saved to be useless, to be wasted space. Okay. The so the second thing that so what would happen afterward would be that the kernel would need, after that, the kernel would need to manually save all the register it fears losing while processing the interrupt. This would be done in software and is very slow. Now, if that doesn't sound bad enough, let's take an example of a syscall. Syscalls would work in a similar way, but they don't have the advantage of the CPU constructing the IRET frame for it. This means that the kernel had to save not only the this means that the kernel had to save not only, let's put some comma in there. This means the kernel had this means the kernel This means the kernel had to save not only the register that it fears losing, but also the IRET frame in software. This is very slow, but was the only way to keep compatibility. Keep in mind, the same idea exists since x86 inception, creation maybe? x86's creation. Now, what about Fred? Fred works by changing the behavior of the CPU when it comes to events. So Syscall will now create the new Fred frame onto the stack, just like an interrupt would. Interrupts and exception will leave more information within the new Fred frame. The CPU now has specific instruction that are kernel mode and user mode dependent. This leaves less work to the software. This leaves less work to the software that would have to triple check things. Maybe double check would feel more natural. Double check things when an interrupt, when an event would happen in a kernel mode context. Let's do the same exercise we did with IDT, but with the new Fred feature. Syscall is executed. The CPU will now generate the Fred frame, which now looks like this. I guess we can copy over this because it... Okay. We had it written somewhere, right? The full freaking frame. Maybe I should stop opening 1500 freaking windows. Maybe? I don't know. Who does that? Who does that? Open 1500 windows? I don't know. Sounds like me. Sounds like me. Okay. Where the fuck was I? Oh yeah. Oh, that's why I don't like opening windows. It's because I don't like showing my bookmarks. Because I haven't checked if there's some dumb shit in there that I shouldn't show. God damn. That ain't smart. That ain't smart. Am I retarded? Might be, might be. Oh yeah, I'm retarded. So essentially that's what it saves. I'll put that on my second screen in order to copy it over. The event data. Hi, Ion. How's it going? Double LO. LO. All right. Let's not stop. Okay. So this is the time where you might say maple. Besides the padding and the event data, nothing changed. But this is where the Intel, yeah, fuck it, Intel engineer, that's not how we write that word. Thank you, engineer. Are being very tricky, smart, are being very smart. I don't care. I won't even use the same word when I'll freaking read it. But this is where the Intel engineer are being very smart. Meow. Hello, Rust. How's it going? Um, we're getting there. We're getting there. Meow. Are we repeating everything twice? What the fuck is this? You're tricking me, guys. You're trying to fuck with my mind. I'm like, ah. But this is where the Intel engineer were very smart. Remember the space. What do you mean twice? Oh, you're fucking with me. Oh, you're fucking. I know you're fucking with me. I know. Rust, you little shit. I know you. I can see you. Okay? If it repeats, I'll fucking. How fucking. How lit would I have been if it were to double? Like it goes again. Ah! Okay. Remember the space that was taken by useless information in the save registers. We now use that space to store additional information. thread being a feature that is only available for IA32E long mode, or simply said 64-bit. The E here is a small e. Okay. Makes it so we can assume most of the bits within the SS and CS register. We also see a new concept appear. Okay. Stack level. Okay. If I were good at editing videos, that's what I would do. And now we're talking about stack levels. Make the kernel way more intense than what it is. Each time I say what it is, or just is at the end of something, I cannot like not think about this.
The missile knows where it is at all times. It
It's
knows
so
this because
retarded.
it knows where it isn't. By subtracting where it is from where it isn't, or where it isn't from where it is, whichever is greater, it obtains a difference or deviation. The guidance subsystem uses
All
deviations
right,
to generate
we're
corrective
doing this.
commands to drive the missile from a position where it is to a position where it isn't, and arriving at a position where it wasn't, it now is. Consequently, the position where it is now the position that it wasn't, and it follows that the position that it was is now the position that it isn't. In the event that the position that it is not the position that it wasn't, the system has acquired a variation. The variation being the difference between where the missile is and where it wasn't. If variation is considered to be a significant factor, it too may be corrected by the GEA. However, the missile must also know where it was. The missile guidance computer scenario works as follows. Because a variation has modified some of the information the missile has obtained, it is not sure just where it is. However, it is sure where it isn't, within reason, and it knows where it was. It now subtracts where it should be from where it wasn't, or vice versa. And by differentiating this from the algebraic sum of where it shouldn't be and where it was, it is able to obtain the deviation and its variation, which is called error.
Cool. Thank you. Okay, stack level. A new concept appear. Stack levels. Stack levels are the solution that Fred uses in order to make sure that we should be running in kernel mode or user mode. Keep in mind that stack level doesn't equal in any way to... Oh yeah, I'll give you a recap in a quick second. Keep in mind that the stack level doesn't equal in any way to the privilege. I don't know how to write. Privilege. level that okay. Can you give a high-level recap on the general use case and mechanism of Fred, and for what purpose are you researching it? I'm researching it for the kernel video that's coming next week. This will be, like usually in the kernel video, I have like one subject that is deeply fucking research at the start, and after that it's like, we could say slop, but just like a summary update of what the fuck's going on. And this is the thing that I wanted to research because, whoops, because it is a big thing. So, Fred, well, we can just go through this because that's essentially the best outline. So, when we talk about Fred, we talk about flexible. Okay, yes. Okay, flexible return and event delivery. So when we're talking about events, we're talking about interrupts, exceptions, syscalls. So it's now enabled by default for CPUs that are compatible with it. Right now, it only means the Intel Panther Lake, but we'll see Diamond Rapids, so the future Intel CPU, and also Zen 6 from AMD. Yes, because this is a feature that will be true for both AMD and Intel, so that's good freaking news. That's because of the x86 ecosystem advisory group. Now, the goal of Fred is to be able to to change the way we do interrupt, that we do exceptions, that we do syscalls. So I'm sure you know, because from what I've heard from you, you're a smart guy, okay? You're a very smart guy, and you seem to be fucking around in, in that kind of territory. But the issue with x86 and, well, specifically x86 64, is that there is no facilitation for the kernel mode and user mode, like the detection of that within the CPU. So there's no command that makes this easy. There's, of course, the loss of register value whenever you have an interrupt. So if you have an interrupt and you have another interrupt after that, you've lost data unless you've saved it manually, which is a pain. And also, you have limited information that can be passed along by your interrupt. So let's say that you have an exception or you have an interrupt and you want to essentially say, hey, that's the source of the problem, and this is the data that we can get from this specific interrupt. That's not really a possibility right now, unless you pass it through your error code. But my understanding is that you don't really have flexibility on what you put on that error code. That's like an already like determined standard. So it's not as if you can put whatever the fuck you want on there. So those are key issues that needs to be fixed. So like we can go and do like a TLDR on how IDT works, so the interrupt descriptor table. So that's how we currently work. Now, whenever there's an interrupt, we have the stack. We get a bunch of shit that is pushed onto the stack. So we have the stack segment, we have the stack pointer, we have the R flag register, we have the CS register, the instruction pointer register, and we have the error code sometime. Now, this forms what we call the IRET frame, so the interrupt return frame. Now, the bad thing with this is that it saves a bunch of shit that is already something that we like know, that we can magically divine from the fact that we are on a 64-bit machine. So if you go look at the documentation, like like all of that information can be divined from the fact that we are on a 64-bit machine, right? So there's a bunch of data that are stored currently within that stack that is absolutely useless. So all of that is put onto the stack, and then whenever we want to come back from an interrupt, we can just launch the IRET instruction, and ta-da, we load everything back into the right place, and it works pretty well. Now, the Other issue here is that syscalls don't have that. So whenever you launch a syscall, it's the kernel that itself creates its own iret frame to return from that syscall. So there's no magical ability for the CPU to put everything in order onto your stack for the kernel. So it's a slower process than if there was an automated instruction for it. So that's also an issue. Now let's go look at Fred, at how Fred does it. So Fred does it by making sure that everybody is going to have their little piece of, we could say the new iret frame. I'll call it the Fred frame. So if you launch a syscall, if you launch an interrupt, if you launch an exception, you're going to have that Fred frame that will allow you to save information into it. Now, it will save additional information. So there's some reserve padding. We have event data, which can already give more information about what the fuck just happened. And also the same information that you would have in an iret frame. Now, the big difference here is that your SS, your stack segment, your CS, your code segment registers, those registers now are optimized and contain more usable, more workable information. So like I showed you a little bit earlier, here, all of that information that is essentially divined from the fact that we're using 64-bit and Fred is only compatible with 64-bit, so you can just assume 64-bit. And same thing with SS. So the fact that we can divine that information means that we can now store data onto these bits that we couldn't before. So now we're storing more information there that allows for like things to go faster. I have no fucking clue outside of that. Like, I'm sorry, but we're getting way too far into my brain. I'm not smart enough for this, but we store more information, all right? So the crude result of this is we don't have to manually write things onto the stack for syscalls, so that's already faster. We have a new concept called stack levels, which, if I can TLDR the fuck out of it, is essentially a way to easily see if we're currently running in kernel mode or user mode. So by looking at the stack level, we can see, A, are we at the right place right now? Are we in the right stack that we should be running this shit? And B, like, are we actually in a specific privilege level that we want? And also, Fred will flatten the privilege levels. So even if it's technically possible to extend Fred in order to have access to the other rings, so ring 1 and ring 2, the ones that we don't currently use, Fred will assume, and for now always use, ring 0 and ring 3. So you can use some new cool instruction called ret u, so event return user, and ret s, event return system, and they will essentially assume that you're either returning to the user or returning to the system, which allows for faster things to happen, right? Because you can return and set everything correctly for your user space, or return and set everything correctly for your user space is not the right word, but for your user mode or for your system mode. And it will also check at the same time, hey, are we currently in kernel mode? Because that's kind of an issue if you're running this and you're not in kernel mode. So TLDR, CPU does a bunch more shit that we technically could have done before, but for compatibility reason, we never did. I hope this was as clear as humanly possible. And I skipped the very default understanding of what a stack is, because if you don't know what this is, and you're being a kernel dev, I don't fucking know what I'm doing, bro. I don't. Alright, but I need to explain to the folks it could be the fact that we can enable automation that wouldn't be possible with those registers being free. A register being free means the compiler is free to use more register. Well, the core optimization here is that we have pushed most things, most things from software to hardware, and I agree with everything you're saying for registers because I'm not sure I fully. No, I do. Sorry. Okay. There's some magical things within stack level. It's very fucking complicated for me, okay? There's some magical things within stack level that allows us to check if the interrupt your like that allows us to go essentially 15 moves forward and create a stack if we need to create a stack and not create a new stack if we don't need to create a new stack, which also makes things faster. But the big gain is just making sure that we have things done by the hardware that were done by the software before, with the additional security from making sure that we're at the right privilege level. And all of those checks are done within registers. So yes, I would absolutely agree that it's faster in this way, because before you would have to query the IDT, and the IDT points to real memory, so that's slower. To your RAM. But yeah, I just don't know if the compiler actually will use more register, because it feels like we're talking about just fundamental registers here that are not managed by the compiler. Well, they always are, but I don't know if you get what I mean there. There's some registers that your compiler won't fuck with unless you explicitly tell it to fuck with it. And those, my feeling is, they are that type of register that only the kernel will mess with it. All right, that's a better way to word it. Wording! The problem here is that I can like infinitely search this in order to understand it. But there's like diminishing return, and I already feel that I'm way too far to be able to explain this to a layman audience. Because I need to keep in mind that I cannot be like full on scholar, PhD level. We're going to talk about bits. Because nobody will understand jack shit. But also, I don't want to be pure slop. So there's a balancing act I have to do right now. But yeah, I've already researched this too long. Such is life, such is life. But there's also like other gains that comes from this that I'm not talking about, like the non-maskable interrupts. My understanding is that if you add like non-maskable interrupt that calls a non-maskable interrupt, which I don't fucking know how that would be even possible, but like that makes no sense to me. But if you have that, before, the fact that you were launching an IRET instruction at the end of your second non-maskable interrupt, it would allow another non-maskable interrupt to come and interrupt your non-maskable interrupt. So that was like a thing that they weirdly patched in software by doing weird shit, and it's now patched on the hardware side because IRET, the new IRET thing doesn't, well, the ERET system, the event return to system, doesn't do the thing that IRET did, which was just say, hey, we're now open for business, bitch. Non-masculine interrupt. True, it's some trans interrupt. It is very possible to have nested in MI. In fact, it is one of the things making the bug fix much harder. Yeah, that's but keep in mind, when I'm speaking about NMI, I learned what an NMI is for this video. Okay, I'm by no means a scholar. I'm the guy that's like winging it. Okay. One of the easy way to make nested NMI is perfect event overflow. Yeah, my understanding is exactly that. That whenever you want to trace or do anything like I just have benchmark, but perf is the best way to say it. But yeah, when you want to like see how an NMI works or how an NMI perform, that's where you can get nested NMI, and this is where your shit can get fucked. So yeah, no, they're doing it. They're fixing it, and like there's a bunch of cool things like technically your kernel manages the GS segment, and the GS segment is there to like point to where the kernel is in order to to run commands linked to that. And um before there was like no simple way to handle it, but now it's like all fused together and everybody's happy and it's working. And it's saved within that magical stack. So yeah, magical Fred stack. Intel processor trace. Sounds like they have your pain into consideration at Intel. Ever thought about working for them? We need insiders, okay? Think NMI, CPU, oh shit, interrupt. Yep, that's how I'm thinking about that. Like kernel watchdogs, yeah, power button, critical failure. Yeah, but like your technically everything you said is true, but technically, if you want to trace a thing, right, that's also an NMI. Isn't that the thing? Or maybe I'm retarded. Oh wait, no, I'm retarded. Whenever you want to do something off an NMI, you wouldn't by default need it to be an NMI, right? You couldn't execute a maskable interrupt off a non-maskable interrupt. That would be retarded. I guess that's why. Okay, okay. I think I'm getting things. Okay, I think. Like here, they describe all the things that they add within the just the SS register. Like, there's so much shit. It's so cool. Okay, okay. I need to finish my yap. I need to fucking get there because right now. So the TLDR is Fred equals new instruction. Yeah, but it's bigger than that, right? Because it changes how we use currently, like the syscall instruction doesn't work the same way whenever Fred is on. So it's not only new instructions, it's also current instruction don't work the same way. So, yeah. And again, it's so cool that AMD decided to go all in with that because it's a standard that will be like universal. We won't have this disgusting shit wherever like, oh, I have my AMD only instructions. And then you have your Intel only instructions and you're like, okay. I'll compiler -O3 kill myself. Okay, that's what I'll do. I'll I'll max optimize my suicide through the compiler. All right, all right. I love yapping. Where's Arm though? Who the fuck knows? Arm, our savior. Oh man, I'm spitting. Shouldn't. Like we're I feel like I was so young whenever we were talking about like, oh my god, ARM's coming, we're all going to have ARM computers, it's going to be so cool, it's going to be so fast, so optimal, and we're still here like, where the fuck is ARM? Well, I guess they're getting there with is it Snapdragon X10 or X1 or something like that? I don't know. They're getting there, but it's just a weird thing. It's the same problem that games have on Linux, right? Everybody uses Windows, so people will only make work for Windows, so nobody will use Linux for gaming, so you will never have games for Linux, and then doop 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 doop. Risk 5 is better. I like Risk 5 just because of the fucking giga roast that some dev had happened to him. Where his ass got fucking blown out. Um which one was no, that's not the one. Like the one where Linus is like, what the fuck is this? Risk 5 is the worst about CPU specifications. Oh yeah, that's that's such a war crime. There's like a million extensions with CPUs inputting different one. Um, yeah, Big Indian. That's the one that like blown up. But yeah, it's like I understand the idea of Risk 5 and like all the instructions, and it's a good idea, right? But the truth is, if your core is not standard, you won't get anywhere, right? You cannot you cannot just say, "Hey, everyone, we're not even going to attempt to have a standard. Just do your own shit, and then we'll sign on to it as if it's official." Like that's not good. There should be at least an attempt for like, okay, this is how we do this specific kind of things, and maybe there's 15 modules to do that, but like this is the attempt to standardize it. Like I'm sorry, but there's no world. I I think there's nothing more blackbilling to Risk 5 than reading their specification. Like, what the fuck is this? No! And there's like one page per instruction here, right? While on the Intel side, when you look at the same thing, there's like 15 page per instruction. This makes the world actively a worse place to live. True. Yep. That's what he said. He's he's the man. But like I don't know. The problem here is that it's like I need to stop saying it's like fuck. Um the problem here is that Risk V started off as the open source thing, and they never tried to be serious after that. It just feels like they're just the open source thing. So, yeah. Like ARM can hold everything together because they never pretended. They're just like, we hold you by the balls. Go ahead. Be ARM 64, okay? And follow our track. Or else we will enforce our copyright and destroy you. ARM 64, you will. Okay. 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 I need to get this shit. Okay. Stack levels. Stack levels are the solution that Fred uses in order to make sure that we should be running in kernel mode or user mode. Keep in mind, the stack level doesn't equal in any way the privilege level. Once an interrupt is executed, Fred will look inside of a new register called get me my register name. Can I get that stack? All right, Fred. Haha, that's my boy. Fred the YouTuber. I know a Fred as a YouTuber, but that's back when I had a French channel. So, no, that's not the same person, okay? Back when I had a French channel, I went into what we call the crusade, where I essentially killed, um, well, two YouTube channel for French Linux. One of them was like one of the biggest French channel for Linux. That was well, they fucked with me, so you fuck with the maple, you get the nuke. But was back when I was a teenager, okay? So shit was fun. Once an interrupt is executed, Fred will look inside the of a new register called IA Fred stack levels. Stack levels. This register is to be considered an array of 2-bit stack of 32 2-bit stack level linked to the first 32 in interrupt code. How do we say that? Interrupt table entry like the keep in mind that spread the cycles the same numbers for the interrupt within IDT. So when executing an interrupt, it will check if it needs to create a new stack based on if the stack level within D is higher than the current stack level. If that is the case, Fred will use the corresponding pointer within the four new registers Why the fuck do I know this by heart now? I feel like the more that I'm reading these documentation, the more I'm becoming like big brain. I have so much IQ points right now. Look at my IQ. It's over 9,000. That's the mean, right? Return type pointer MSR. Okay. -5 IQ. Oh, man. Get me the IQ points. Okay. These registers contain a pointer to a free space in memory to start a new stack. This allows for faster execution. Brain. I don't even know how I want to explain this. Bro! I don't even know if I understand it. Okay. Stack levels. Stack levels are the solution that Fred uses in order to make sure that we should be running in kernel mode or user mode. Keep in mind that stack levels doesn't equal in any way to privilege level. Once an interrupt is executed, Fred will look inside of a new register called IA32 Fred stack level. This register is to be considered an array of 32 2-bit stack level 2-bit stack levels linked to the 32 interrupt numbers. Keep in mind that Fred recycles the same number for the interrupt within IDT. So when executing an interrupt, it will check if it needs to create a new stack based on if the stack level within the IA32 Fred STK stack level is higher than the current stack level. If that is the case, Fred will use the corresponding pointer within the 4 new register, IA32 Fred RSP stack pointer. That stands for stack pointer. RSP0, so stack pointer 0, and it goes from 0 to 3. These registers contain a pointer to a free space in memory to start a new stack. Okay, I just thought the most epic demo even ever created by Microsoft. There's a lot to do here, okay? There's a lot to do. Okay, send it over, brother. Grep! Ren include? The fuck is this? The fuck did I witness? Are you fucking kidding me, bro? So, okay. I don't know if I should kill myself or Landuk recommendation. Yeah. No. uh oh man. Okay. I need not look at this, or else we'll go down a spiral that we don't want. Okay. To go along with all the changes with another change that comes with Fred is the new instructions E red U and E red S, which returns either to fucking out user mode or kernel mode, and removes some of the steps that the kernel would usually have to do itself in these transitions. I think that if I go further into my explanation, people will have completely tuned out. And I don't really know how much further I can go. So I'll make sure that we stop it there unless we have more shit to talk about. I don't know, I feel like stack level, not what I wanted to do. I feel like a stack level, I've explained it like shit, but I don't even know I fully understand it. Like I went to this step-by-step thingy, but is it that starting a new stack is an... Oh, that's probably it. Starting a new stack is probably a resource-intensive thing. Like, technically, you would have to query the kernel or to have an address somewhere that you can get. So I guess that having some of these on the side ready to go would allow execution to be way the fuck faster. That would make sense. I guess the best thing I could do would be to go into the performance change. Okay, let's make it small. It takes half an hour to scroll. Oh! Do you have anything on performance gain for the video? Yep, I'm going there. That may be what people want to hear, absolutely. Probably most interesting in IO-bound context switch workload. That seems to... You're a fucking genius, brother. That seems to... Oh, what the fuck is this? Look at this bench. Holy. That's... unhinged. Um... I was thinking about like, oh, we're gonna get a 7% boost. Brother, that's a bit more than that. Alright, Chief. Okay, in gaming, okay. Okay, can we have the geometric? That's insane. I don't see any difference. You sound like a Londuke viewer right now. I don't feel the difference on my machine. That's insane geometric mean. Holy shit. PostgreSQL them. That's a 60 performance indeed. Like, can we, well, first of all, flexible IO. What the fuck is going on here? Can we have the, PostgreSQL? God! What? Lee! That's... Like, I don't fucking know, but if I were a dev for PostgreSQL, that's whew, that's indeed some fucking, this is, whoa, guys, don't look. We're going to go live on Pornhub later. Like, what the fuck is this? Okay. All right. So we'll yap about this. Just give me a moment. I'll come back. All right, I'm back. Coom. Okay, it passed by my mind, so I want to check. God damn, that's a dump. Barrow. Okay. 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 We're doing still fine. Pretty good. Okay. So, Fred comes with one of the most massive performance gain we have seen so far with no, that's not what I want to do. That's not what I want to do either. Okay. Okay. What's the name? IO tester. Flexible IO tester. Flexible IO tester. Getting an almost 2x performance gain. And PostgreSQL SQL having massive gains as well. I think that the most surprising thing is how universal the gain is with a normal change in feature. We would see some loser and winners. Some losers and some winners. Where here we are winning across the board and in pretty impressive. And in a, how do we say pretty? 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 Okay, pretty impressive way. And in a pretty impressive way. Gives us an incredible gain in the red looks in the show. Nah, I don't need to address it. Okay, cool. Fred comes with one of the most massive performance gain we have seen so far, with some tasks like Flexible IO Tester getting almost a 2x performance gain, and PostgreSQL having massive gains as well. I think that the most surprising thing is how universal the gain is. With a normal change in feature, we would see some. Yes. With a normal change in feature, we would see some losers and some winners, where here we are winning across the board and in a pretty impressive way. Oh, freaking K! Caveat is you need to support a superior server. How about that? Yeah, well, the thing is, I don't even think I need to say caveat, right? Normally I would caveat the fuck out of it, but here there's literally no loss anywhere, right? It's an overall win. And yes, there are tasks that it's better at, but I think that's like we if someone is not able to understand that by default, they're retarded. Well, that was pretty dramatic, but yeah. Like I'll oh, okay. Yeah. You need to think into your head what I'll show while I speak, right? And what I'll show is I'll show the good result, the medium result, and the geometric means. So it should be pretty obvious that like we have gains everywhere, but it's not magical, of course. Okay. Okay. So let's fucking and okay. So let's what's next? Let's see what's next. Because we're essentially reading the Pharonics page. We're vibing, okay? Okay. All right. Uh, okay. No. No, no, no. AMD CPPC, okay? The Communist Party of Philadelphia Corporation. Okay. So, power management subsystem. Whoopie-doo. The AMD P-State driver added support for CPPC performance priority, dynamic energy performance preference, and raw EPP. These are nice feature addition for the AMD P-State driver that continues working out rather well on modern AMD Ryzen system and EPYC servers. Those new AMD P-State drivers are all well explained in length in prior article. Okay, well, I'll read it then. Um, I feel like didn't we have that before? Like if I search on this, not Zigbop. Okay, that's an Intel thing, I guess. An ACPI thing? Okay. Ah, okay. Cool. All right, read. AMD State Driver introduced new feature with Linux 7.1. A few Linux kernel releases have passed since there have been any new feature to talk about with the AMD State Driver for CPU frequency scaling and power management with the modern AMD Ryzen and EPYC processors. But for the upcoming Linux 7.1 kernel, there are some nice features now ready for mainline. There are a few new features for the AMD State Driver with fixes too. Mario Limoncello of AMD, who has now taken over as the formal AMD State Driver maintainer, sent out a new pull request today for queuing in the power management subsystem. Okay. First up is the AMD CPPC performance priority features set for inclusion in Linux 7.1. The CPPC performance priority lets the user space assign a different floor performance level to different CPU cores. The platform firmware will interpret these floor performance level for consideration when throttling CPU cores under power and thermal constraints. With the AMD P-State driver, new floor frec and floor count sysfs attribute are exposed for letting administrator or user space configuration daemon adapt the power management. Ooh. Okay, that's cool. So, um, you know what? That could be a feature. That will be a feature. AMD. Giga. AMD. New features. AMD's new features for the state driver. AMD has a big AMD's the state driver. The driver that controls our the chip. With a couple of features. CPPC. The AMD CPPC performance priority. This new feature will allow the administrator to slash user space to set per four floors and when we're saying floors, we're talking about frequency, right? for frequency that the CPU will take into account when pressured by throttling events like overeating, um, or power limitation. This is exposed using it was Sisyphus using the new floor frec and floor count Sisyphus attributes. Oh, we have another thing. Let's remove AMD here. It's clear that it's AMD. Okay. Dynamic energy performance preference. Ooh. Dynamic energy performance preference allows changing the EPP value depending upon whether the Ryzen laptop is, goddamn, that's weak, is running on AC or DC power. The EPP value can be dynamically adjusted based on the power supply plugin or plugout event. Dynamic EPP can be enabled, disabled via the Linux kernel kconfig or via boot time option if so desires. Okay. I'll rip all of this, okay. The EPP value. The EPP values. This features seeks to modify the EPP values based on the based on if the power supply of the laptop is plugged in or not. Remember, EPP values can have drastic implications on the performance slash power on the performance or power consumption of a laptop the fine tuning, define tuning of these EPP values is where most of the gain is where a lot of the performance gain of kernel updates can be seen. Okay, this feature seeks to modify the EPP values based on if the power supply of the laptop is plugged in or not. Remember, EPP values can have drastic implications on the performance or power consumption of a laptop. The fine-tuning of these EPP values is where a lot of the performance gain, I guess, yeah, fuck it. Performance gain of the where a lot of the performance gain Okay, the fine-tuning of these EPP values is where a lot of performance gain can be seen. Fuck it. Dynamic EPP can be enabled and disabled. Dynamic EPP can be enabled and disabled. And disabled. Yeah. Is it default? I guess we'll have to check. Oh, here it is. Or no, I guess we don't have access to 7.1-RC1. Oh, okay. Cool. I guess I have to Google my ass for it. Dynamic. Mario. God damn. That's a full years old. Okay. Okay, so it's inside of kconfig thingy. x86. Okay. I need my bachelor's in finding shit inside of the Linux kernel. Aha! Oh no, is it a remove feature? Getting removed? I don't know. Ooh, looks like they removed it. Wah, wah. Wait, what was the line here? 73. UT? P-state default mode. Still no bootleg. True. Oh no. Shit. Um, okay. When was it removed? I wanted my line 73, you dipshit. Okay. And still no Claude. No clue, no Claude. Oh man. You're roasting me right now. Oh boy. Ooh, okay. So at 5 they removed it. God, that's violent. I should probably search by his name, right? Because he's going to be the one tearing it out. Mario, where the fuck are you? Womp womp. Okay, so they didn't remove it. Why is the mail always so? Yes, this is why I'm trying to do kernel info, okay? This is why. It's because it's shit. Yes, the mailing list is AIDS. And as long as I will be breathing, I will be trying to make something that makes it better, okay? I'll do it. I'll do it. Okay. Well, does that mean that it's default, or what the fuck am I supposed to say? What am I supposed to say? Shit. You know what I love? Being fucking lost. Gotta love being lost. Whether this behavior is a button fuck, command line option is. What the fuck does that mean? Yes, this is what I want to do, okay? Through all the versions. It will be AIDS, but it will work. I will do it. I am the builder, okay? Bob the builder. Okay, what the fuck am I supposed to do with this? The AMD state driver supports dynamically selecting the energy performance profile based on whether the machine is running on AC or DC power. Whether this behavior is enabled by default depends on the kernel command line option AMD dynamic EPP is set. This behavior can also be overridden at runtime by the sysfs file. Is it default or not? What am I supposed to do? I guess it's not default. You need to set it. When set to enable, the driver will select a different energy performance profile when this machine is running on a battery or AC. The driver will also register with the platform profile and alert to receive notification of the user's desired power state to react to those. When set to disable, the driver will not change the energy performance profile based on the power source and will not react to user's desired power state. Attempting to manually write the energy performance preference as a fast file will fail. Oh, okay. When EPP is enabled. Okay, cool. Okay, so I'm assuming that you need to set it in order for it to work. Okay. Via a new boot time option in the RC5, they removed the config option to disable it. Okay. So we're going to quote the fuck out of this. Don't you dream about a day where we're going to be able to make those super fucking notes and just make everything work correctly as it freaking should? Whoop, whoop. Raw EPP. Get me in. Get me in. Okay. Lastly, the new raw EPP feature. This overcomes the limitation of the EPP value being an integer between 0 and 255, but the user configurable option tend to just be one of 4 preset values. For further tuning of workload performance, raw EPP allows specifying a 0 to 255 value in the sysfs file for the EPP rather than relying on a static option. Wow. Okay. Raw. Let's add 4K onto our title while we're at it. Raw EPP. Like, this makes no sense. What the fuck are we talking about here? Why the fuck is that a thing? Okay. No answer. Thank you. Thank you, everybody. Thank you. Why the fuck does that exist? Your guess is as good as mine. Ha! You can go Google it yourself. Oh man, I'm lost. Okay. Oh, yes. I like going to a different website each time I want to go to the mailing list. We have LWN, we have LKML, and we had lore.kernel.org. Did we have another one while we're at it? Do we have any other one? Any other choice? Yes, I absolutely want to print it, bro. Okay. Dynamic EPP allows the kernel to register AMDP state as part of the platform profile. It will change the EPP mode, matching the user's preference to the platform profile sysfs file, as well as a power adapter state. Raw EPP allows the users to write integers to the energy profile reference. This is based off Superm Linux Next. Besides just subscribing to the list via email. Well, even that, right? You're not getting. Oh, okay, you're getting another option. Okay, I get it. I get it. Okay, okay, you're being it. Ah, okay. Yes, yes. I need my emails as well. You know, that's what I want. This sounds like the most graphic, AIDS-ridden way to do this. Yes, I'll read each emails that come in. I'll probably have to do that whenever I implement this to kernel and info, but hey, who gives a fuck? I'm just confused about the fact that they were not doing this before. This sounds a little dumb. So you're telling me that if I go take a look, it would tell me, we got like a couple of ways to do this? Oh no. Fuck, that's truly how they did it. Feels bad, bro. All right. Okay. A raw EPP. For the EPP value would be set by one of four modes, which would manage before you would have to select one of four modes to manage your EPP value. You can now set it directly to the value of your choice between 0 and 255. This sounds so dumb. Okay. Let's delete all of this before I become insane. Do we care about Intel? We don't care about Intel. Risk V. Let's delete. All right. So we got an handle on this. Support for 12 new SoCs and other ARM and RISC 5 hardware platform. Did I say RISC V for all of them? Always come RISC 5 in my mind. Orion? Sounds like crayon. That's kind of a weird word that we have here. Like I'm expecting an I here, not a Y. Okay, for real, do we care? We don't. Ooh! ARM now has real-time support. 32-bit ARM. Get me in. ARM. 32-bit. 32-bit ARM now has real real-time support. It now comes in line with all of the other boys. Let's go see everyone that does real-time. Oh, maybe we have it in documentation. Linux documentation. Real-time. No. 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 No, I want the Linux documentation. Oh, okay. Whoops. Maybe written like an actual human? Okay. Why can I not have an essay and have an actual thing? Oh, I know, I'm dumb. We're supposed to be talking about preempt. Preempt. The theory of preemption. Porting an architecture. Okay. 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 ARM64. Long Arch. RISC-V. x86. Wait. Oh, that's the previous version. Okay. Okay. I was getting baited in real time. We have an RC6, right? ARM. Ta-da! I heard harm. Q King! How's it going, Q King? How's it going? We are currently preempting the fuck out. Okay, let's copy this. It now joins ARM64, long arch. RISC-V, and x86 as the group is as the RT in the RT compatible crowd. Good. I haven't been here for a while. What kind of new project is this? Oh, that's just the kernel vid. So we're doing the kernel video. And after that, we're back to kernel info because that's all we're doing. And we're making progress there too, but yeah. We're making some progress. I swear we are. But yeah, that's the spoiler for the next vid. Kernel info will be great when it's out. That's the, yep. If it come out, it will. You're talking to a guy that is officially, if I start like at the seed idea of kernel info, it's been a year, okay? It's been it's been a year that I'm on this. So yeah. Don't worry, it will come out. I've learned Python. I've learned libclang. It felt like, well, the streaming part of things, that has started like what, in November maybe? So I haven't streamed all of it, right? But yeah. But I've streamed every day essentially, so you can count the number of days with the episode number of this episode. I don't know, how far are we? How far are we? 158. Alrighty. It's almost half a year. God damn. Half a year of streaming every day. That's some dedication to the job, I guess. All right. 32-bit ARM now has real-time support. It joins ARM64, Long Arch, RISC-V, and x86 in the RT-compatible crowd. That is a lot more than I thought. Indeed. I'm the kind of guy that never gives up. Don't know if that's positive, but that's what I am. Oh no, it's not out already. It will be out soon. I prepared a video before it's out. It will be out next week, on Sunday. Am I mixing it up? No, Sunday. So I do the research beforehand. I try to wait at the last minute because that way we know what is in and what is out of the kernel. And that's why you have these fun videos. Do we have some information here that we care about, or is it just like, oh, we have a preempt? Oh, fuck. It was written. It was written. Should have just checked. Okay. Okay. How you doing? Apart from that, do you have some project, Q King? What's going on your side? Besides working and working and working. Real-time entry indicated. That's real-time kernel. Okay, cool. Cool. Yeah, let's yap about our PC is still in the works for RT. I was working on an OS, but got sidetracked, and I'm working on a web framework in pure C, so HTML will be C, just like blade.php. I don't know what you mean by blade.php, but that sounds cool. Working on an OS is the best way to get sidetracked. I gotta say that. Like, I feel like each time that I watch the the Discord, I have like one one chance out of two to be looking at someone that is talking about making an OS. I got GUI in the OS, but networking was so hard. God damn, that's pretty cool. Laravel Blade. Oh, okay. I think I get it. And I got a desktop thing, if you can call it that. Well, having a display is already good, right? So let's be honest there. Let's be honest. It's already pretty cool. Dude, the mainline Linux kernel has begun removing support for Russia. Russia's Bacal CPU. Du-du-du. What did you say, son? Oh, that's an interesting things. Along with these removal, we also have seen the removal of Russia's, I guess it's written here, Russia's Bacal CPUs. After Bacal CPUs were Russia's homegrown CPU solution, but as a result of the war, of their war against Ukraine, the company you just got crabbed on. What if you use your Python skill to scrape this from the web? Oh, sorry. I thought I was in a long do comment. True. Okay. What do you mean there? Do you mean for kernel info? Or you mean for my notes? The reason why I'm doing the note manually is because they're there for me to speak about it. For both, okay. For the note, they're just there for me to A, point to my work whenever I'm done making the video, and B, making the video itself. So that's why I'm writing it. I'm saying it as we go along, is because I want everything to be correct and to be able to make a video about it. For kernel info, I'm essentially doing that. So right now, my only source of data is the kernel Git. So I'm using Git in order to like do my magic. After that, I'll have to download the entirety of the mailing list and process it as well. So I'm essentially parsing the web in some way, but it's just like more respectful local version. But like the project kernel info is a project that will like grow in scope. So like thing number one that I need to do is the kernel. Shit. So I need to be able to parse the kernel and to get the information I need out of there. And after that, with the information I get from the kernel, I'll be able to link it to the mailing list, to like Intel documentation. That's something that I wanted to do as well. Intel or AMD doc, right? Fuck. So like the idea of kernel info is making a base that is good enough that we can then map things onto it and do cool shit with it. So that's why it's taking so much time. It's because I need to have a way to parse in a precise, perfect way that has probably never been done before for this purpose. So yeah. But we're getting further in my latest way that I'm parsing things. We're at the point where all we need to do is to take the new evolved parsing result, shove it onto the web, onto the DB, and then draw that to the screen. To be honest, I like working on software that runs on Intel CPUs more. I prefer AMD for anything else. Well, that technically, that was the goal from Intel, right? Like for a very long time, whenever you wanted to play games, Intel was way better because the people making the games were running it on Intel CPUs. So all the optimization were all made for that, right? So even if you look at the benchmark and we're like, oh, AMD is the same as Intel, it was like, nah. But that's like not true anymore, sadly. Well, sadly. Depends on what you're using. I'm using AMD, so it's not sad for me, but I have a 14 myself. Haha, that's a good fucking CPU. That's a good CPU. I like it. I have a Ryzen 7 3700, right? I don't care about this anymore. What I care about now is my GPU because it's new. I just bought it. 3700X, okay? And look at this Majestic RTX 5070. That shit absolutely blows, okay? I should upgrade my RAM and CPU and GPU. Upgrading RAM is useless. Like changing the frequency of your RAM is increasingly retarded. And especially if you're on DDR5. Wait, am I fucking up my things? I mean more RAM. Okay. Thank Lord. Wait, brain. Am I retarded? I am. Yes, okay, cool. Not even using RTX Spark. Oh my. Trying to push up. Dude, how many fish do I need to kill by using water for my making sounds data center, okay? I need to be more hateful in the way that I do this, okay? I need to be more and more hateful. You know what? Let's have some fun for half a second, okay? I was planning to buy some Tesla GPUs. This many bloop. Okay. 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 I should do something else than being on stream. I should go fucking eat. Sounded like the Wii intro for a couple of... Yes, that's the Wii intro, my friend. With the oofs. I have so much dumb shit that Sam gave me.
And through the magic of buying 2 of them,
Where
I
is
have
Sam? I
already
don't know.
taken apart one
We need to call him.
right here.
Sam! 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 With the magic of nuking Russia, we now have a divided state. Oh, we need a mix.
The missile knows where it is at all times. It knows this because it knows where it isn't. By subtracting where it is from where it isn't, or where it isn't from where it is, whichever is greater, it obtains a difference or deviation. The guidance subsystem uses...
Okay, I'm retarded. Okay, where is the program in C-Song? What? I don't know what this is. Ah. Okay. Oh, no! Don't blow my ears! Wanna see it on YouTube? Oh, man. Why the fuck do I have all of this bullshit? Well, we gotta say, this one is funny, okay? I ran so far away, that one, I like that one, okay? But, yeah. Okay! Okay, maybe I should fuck off. I need to eat, okay? So I like you all. I'll fuck off and do more work and probably play Insurgency, because that seems to be the only thing I do. The Wayland Compositor in Minecraft was fun. Oh yeah, I saw that one. Wait. What should I wait? I'm putting this.
Feel like I'm getting deja vu.
Share what you want to see or put on the stream. I'm having like... Can you enable community posts? I don't. Blah, 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 blah. Oh. Okay. I think I did it. Watching YouTube in... I don't know what that means. In YouTube. Oh, okay. Lock CPP for no reason at all. Is that on the main channel? No, not the main channel. I mean your second channel. This is the second channel. Always Maple Circuit Live. There is no way that I'm letting you, little bitch, put anything in community on that pristine channel, okay? Live is main. Fuck off. You will put things on live. I ain't letting you rape my pristine Maple Circuit channel, okay? Oh man. it I don't have like that much subscriber because I've thrown shit at it. So no. Push something. Now. Slave. What's on your mind? You're a retard. Okay. Like, there's so many dumb shit. Like,
that is not the correct way to eat a cinnamon in a roll. That is not the way you're supposed to do it. That is some false ass information.
what's this? Oh. Rust, I won't kick you today. Or will I? Refreshing is the answer? Left my ass off? What do you mean? I also have the Wii menu. That sounds dangerous. I'll pre-lower the sound of this one. What do you mean it's on your YouTube? Reload. Okay. I'm thinking of C. C. True. That's a good post. F5. Which fucking channel did you raid, my friend? Give me the post. You've been banned. Oh! 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 I want to see it here. Give me the rust. No! It's so cute! Is it because I need to, like, authorize it? I want to like it. No! You have been visited by Rust Club. It's so cute! Add as approved user. Sounds fair. Add as approved user. Okay. Okay. Yeah! Look at this shit! Whoop whoop whoop! That's cute. I love it. Approved sound effect. Do I have one? Well, that's my... that's my version, okay? It's my version. C came first. True. And by the by, MB did something kind of cool. I don't know if you were here for it. He is working on... He is working on... Okay, won't find it. Anyway, he's working on a TTS where we're going to have some like individual voice, and it's going to read your comments. It's going to be cool. You're going to be able to shitpost in real time. and maybe even play sound effects. Rust, that sounds like your type of dumb shit, okay? That sounds like you. That sounds like your baguette. You're getting a call. It's happening. You're getting a call. You're getting a Discord call. You're getting a Discord call. Stop opening cans, you fat fuck. Good job. You've stopped opening cans. I'm essentially